Okay, so now we're gonna start applying what we've been using finding our vertex form to making maximums and minimums. We know when we have a quadratic equation, and if we look at this first one, the first thing we need to do is actually make it a quadratic. This shouldn't be a cubic, that should be a 2. Oh, it's really hard to see, so do that and make that a 2. But what we're gonna do is we're gonna look at these and we're gonna state the maximum and minimum values. Well, we know that we can do that by putting this into vertex form because that shows us the maximum or minimum depending on which way the quadratic opens. So for this first one, what we're going to be doing is the same steps we've been doing all along. We're completing the square. So we're going to put the 3 in front. Factoring that out of the first two terms, we get x squared minus 8x and then plus 40. Now we're going to take half of 8, which is 4, and square it. We rewrite everything else, we get plus 16. And then we're putting that back on the outside, but it's gonna be minus 48 because 3 times 16 is actually what we've added. That 3 multiplies in, we need to remember that. So we've actually added 48, so we take 48 away, then we add the 40 in at the end, and our equation looks like this. So we've got x minus 4 squared minus 8. But what we're looking for is the maximum or minimum and when it occurs. That's important because when we start doing word problems, we need to know when things are happening. So here, because this is facing up, that means we have a minimum of y equals negative 8 at, it happens at x equals 4. This is the y value of the vertex. This is the x value of the vertex. Okay, so if we're looking at the next one, we've got y equals negative 2. We're taking that out of the first two terms, x squared. Now we need to make it plus 5x because we're taking out a negative 2. We're dividing it by negative 2. Now here we're going to get a fraction, but that's okay. We've got negative 2. X squared plus 5x. Now I'm going to half 5, so I'm going to get 5 over 2, and I'm going to square it. That's going to become 25 over 4. 5 squared is 25, 2 squared is 4. Now when I take it out of the brackets, I'm multiplying that 2, so that would be either plus, because we have a negative, 50 over 4, that changes to 25 over 2. We can just half our bottom number because we're multiplying it by 2. And then we've got negative 9, and negative 9, if I have a denominator of 2, would be 18 over 2. 18 divided by 2 is 9, so that becomes 18 over 2, just because we need a common denominator to add fractions. So then we get negative 2, x plus 5 over 2, which is just our half number. Half of 5 is 5 over 2, and that's always going to be that second number. And we square it, and then we just add the numbers at the end. So we get 7 over 2, and then we get a max, because it's facing down with that negative, of y equals 7 over 2, and it happens at x equals negative 5 over 2. Again, y value of your vertex, x value of your vertex. Okay, so let's apply these. Let's look at a couple examples on how this actually applies. When you're doing these examples, you have to have a let statement, you have to have a therefore statement. So if I read this, find the two numbers whose sum is 14. That means two numbers are adding to 14. And they have a product that's a maximum. A product is they're multiplying. So I'm going to say let x be the first number. So when we're working through this, we're going to have x as our first number. So I know if I have y equals some product, I'm going to have x is the first number. And the way I'm going to find the other one is I know that the second number plus the first number have to be 14. So then that would mean 14 minus x would be my second number because that's the only way we can get to 14. So now I have to put those terms together. So I get 14x x minus x squared. But we really don't like the way that's written. It's not kind of easy for us to do. And this step isn't necessary, but I'm just showing it. I've rearranged it, and now I'm going to complete the square. So I'm going to take out that negative. We get x squared minus 14x. Because 2 minuses make a positive. Then we get negative. We get x squared minus 14x. Half of 14 is 7. And 7 squared is 49. Because we have the negative out front, we're actually adding 49 outside of the brackets as well. And then we're going to get negative x minus 7 squared plus 49. So what this equation tells us is a lot. It tells me that the maximum that this whole thing could be is 49. I know it's a maximum because I have a negative at the front. And it tells me that it happens when x equals 7. Well, if x equals 7, x is my first number. So therefore, the numbers, the numbers are 7 and 7, because 14 minus 7 would give me the second number. Okay, looking at this last one. So when we're doing questions like this, we want to make sure we have a diagram. So a rectangular lot is bordered on one side by a stream. The other 3 sides are fencing. So I'll even use colors here. So we'll have a blue stream. There it is. And now we're going to have fencing going around this lot. Okay, it looks like that. It's a rectangular lot. I've made a rectangle. Find the dimensions of the lot if its area is a maximum. So our dimensions are always going to be length and width. I know the whole thing adds up to 600. So if I was doing this, I would set my let statement, let x be, and you don't have to use x, you could use anything you want. You could use w or l, be the width in meters. Okay, so we've got our let statement. And you could have chosen the length. It wouldn't have mattered. But if I put this on the diagram, I've got x and x there. There's my width. I know the whole thing adds up to 600. So then that means that my length has to be 600 minus 2x. I'm taking away this side and I'm taking away this side. So now I've got my length and my width. So I can set up my area formula. Area is length times width for a rectangle. So we're going to have 600 minus 2x times x. Then I'm going to expand this out. I'm going to rearrange it in this step as well. So we get negative 2x squared. That's this times this. And then I'm getting the 600. So plus 600x. And now I'm going to start completing the square because I want it in vertex form. So negative 2 x squared minus 300x. And then I'm going to get negative 2 x squared minus 300x. Half of 300 is 150. And 150 squared is 22,500. Really, I've taken away 45,000 because I have to double that number. So I'm going to put plus 45,000 because remember, we're always going to multiply that over. So my vertex form would be negative 2. We get x minus 150 squared plus 45,000. Well, that kind of tells me everything I need to know. I know that my maximum area, so therefore, I'm going to write a whole bunch, a little bit more than I'd actually need. My max area is 45,000 meters squared. The units are important, so always look for your units. We had 600 meters, so this would be meters squared when the width is 150 meters. X was our width. That's the variable we created. And we know that length is equal to 600 minus 2 times 150, which is 300. And the length is 300 meters. So when you're doing these word problems, you need a let statement. Diagrams are very helpful, and you need to include units. Units are very important for this.